to our new video. So the new problem is on the screen, and given data is E is equal to, E means elastic module is given 210 kN per mm square, and I moment of inertia is 16 into 10 raised to 8 mm raised to 4 is moment of inertia. And to find deflection at the points and maximum deflection, first step is calculate fractional rigidity. Next step is determine support reaction. So summation of MA is equal to 0 and calculate 120 kilonewton. So first 120 kilonewton. So its distance from RA, support reaction RA is 3 meter. So 120 multiplied by 3, and downward direction is plus and upward direction is minus. So 120 multiplied by 3 plus 80 multiplied by its distance is 6.5. 80's distance from RA is 9.5. Minus, next load is minus RB multiplied by total distance from RB to RA is 40 is equal to 0. And just calculating it, we get RB is equal to 80 kilonewton. RA plus RB, just addition of these two loads, we get RA plus RB is equal to 200 kilonewton. This is our equation 1. Next is put RB is equal to 80 kilonewton in equation 1, and we get RA plus RB's value is 80 is equal to 200, and we get RA is equal to 120 kilonewton. Draw such a diagram and write down the values of RA and RB. RA is equal to 120 and RB is equal to 80. Now mx is equal to EI d square y upon dx square. So first load is RA 120 and distance of RA is x multiplied by x. So 120x dash dash dash. Here downward load is minus and upward load is plus. So RA is plus. Next is 120. 120 is minus 120 multiplied by x. The distance of 120 kilonewton from RA is 3. So x minus 3 dash dash dash. Next is minus 80 multiplied by x minus distance of 80 kilonewton from RA is 9.5. Bracket complete. This is our equation 1. Mxx is equal to, so integrate equation 1 and we get EI dy by dx is equal to 120x square upon 2 plus add C1 dash 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 minus 120 x minus 3 its q square and upon 2 dash 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 minus 80 x minus 9.5 bracket square upon 2. It's our equation 2. Now deflection equation in terms of constant, integrate this equation 2 and we get EI y. Double integration cancel the dy by dx is equal to, next EI y is equal to 120 x cube upon 6 plus C1, there is a twist, C1x plus C2 dash 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 minus 120 x minus 3 bracket cube upon 6 dash 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 minus 80 x minus 9.5 bracket cube upon 6, and this is our equation 3. When x is equal to 0 and y is equal to 0, so we get value of C2 is equal to 0. So put x is equal to 0 and y is equal to 0 in equation 3 and we get C2, value of C2 is equal to 0. Put x is equal to 0, sorry, x is equal to 14 in equation 3 and we get. So first time you need just put the total length is 14 meter. So put x is equal to 14 in equation 3 and we get 0 is equal to 120. X value is 14's cube upon 6 plus C1 into 14 plus 0 minus 120. 14 minus 3 its cube upon 6 minus 18 40 minus 3 cube upon 6, 40 minus 9.5 cube upon 6, and after solving this we get 54880 plus 14c c1 and c2 get cancel minus 26620 minus 1215. So c1 is equal to minus 9131. This is our answer, kilonewton. So first write down the deflection equation. So y is equal to 1 upon EI 120x cube upon 6 plus C1x plus C2 minus 120x minus 3's cube upon 6 minus 80 x minus 9.5's cube upon 6. This is our deflection, general deflection equation, and put 120. So deflection under load of 120. So put x is equal to 120 distance from RA is 3. So put x is equal to 3 in this equation and we get y is equal to 1 upon EI 120 multiplied by 3's cube upon 6 plus C1 multiplied by 3 plus C2 get 0. C2's value is 0 minus 120 3 minus 3's cube brackets cube 3 minus 3's cube upon 6 dash 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 minus 80 3 minus 9.5's cube upon 6 and the value of EI 1 upon value of EI is 336000 and after solving all of these get 0 because multiply by 0 it becomes 0 0 0 and after solving this term we get is equal to 1 upon 36000 into the bracket 120 3's cube upon 6 minus this all C value of C is minus 1931 multiply by 3 and this all becomes 0 and solving this we get the value of 1 upon 336000 to the bracket 5253. So y is equal to, solving all of these in calculator we get minus 0.0156. So deflection under 80 kilonewton. So x is equal to 9.5 in deflection equation. So put x is equal to 9.5 in deflection equation and we get yc is equal to 1 upon 336000 is into the multiply by 120 into the bracket 9.5 cube upon 6 into C1 multiply by 9.5 and C2 becomes 0, and 120 into 9.5 minus 3 cube upon 6 minus 80 into 9.5 minus 9.5 cube upon 6. 9.5 minus 9.5 is 0, and 0 multiplied by 80 and 0. So this equation becomes 0, and we get the value of yc is equal to, after solving all of these and simplifying, we get the value of yc is equal to minus 0.019 mm.